Good afternoon, everybody. Welcome to the Civil and Environmental Engineering Distinguished Lecture. I'm Shankar Shastri, Dean of the College, and we are excited to be co-hosting today's program with our very special speaker, Dr. Elizabeth Hausler Strand, founder and CEO of Build Change, and a star alumna, I should say, too. So I'd like to give a special welcome to our Dean Society members who are here with us today, as well as members of the Civil and Environmental Engineering Academy of Distinguished Alumni. Later this evening, the Academy will gather to induct the class of 2015. Welcome, and thank you all for your support of Berkeley Engineering, and especially congratulations to the new inductees. I'd like to acknowledge our student sponsors who are helping with today's event. The Berkeley student chapter of the Cal Seismic Design Team, and those are the folks with the college shirts there. In 2013, the Department of Civil and Environmental Engineering revived the tradition of a semi-annual lecture, inviting a distinguished faculty member or alumnus or alumna to speak before the campus community. Our guest today, Elizabeth Hausler Strand, exemplifies this vision. Dr. Hausler Strand is one of our own. She received her master's and PhD here before going on to an accomplished career in public service. Today's event is presented with generous support from the Warren A. and Marjorie C. Minner Endowment. Several years ago, they established the Minner Endowment for Engineering Ethics and Professional and Social Responsibility. This endowment supports the college in our mission to teach our students about ethics and to spark conversations and critical thinking on ethical issues facing engineering students, researchers, and practitioners. This lecture is the result of their generosity, and we thank them for their support. Now, please welcome David Friedman, who will introduce our speaker, and I'll introduce David. 30 seconds. David is a loyal and generous Berkeley alumnus. He's a graduate of our own Civil and Environmental Engineering program. He is the Emeritus CEO, Senior Principal, and Chair of the Board at Forel Elsesser, a distinguished structural engineering firm based here in the Bay Area. David's work includes the base isolation retrofits for both the San Francisco City Hall and Asian Art Museum. He also played a lead role in the seismic safety corrections and remodel of California Memorial Stadium, Blum Hall next door, and most recently Jacobs Hall. So thank you very much, David. Throughout his career, David has been active with many philanthropic, nonprofit, and civic endeavors, and we are currently very fortunate to benefit from his public-mindedness. He is a leading advocate and advisor for our Department of Civil and Environmental Engineering. Please welcome David Friedman to the podium.
Thank you. Safe homes, safe schools in earthquake and hurricane-prone regions of the developing world. Elizabeth Hausler Strand took her multiple degrees, BS from University of Illinois, 2 master's degrees, one from Colorado and one from UC Berkeley, PhD from Cal, and a Fulbright scholarship. All of those to take a non-traditional focus. She founded Build Change. Calling Build Change an engineering nonprofit really does not do it justice. It's an international development NGO, laced with a women's economic development NGO. As you listen today, you will hear a context of social justice. For Elizabeth, safe homes and safe schools are nothing more than human rights. I'd go over my allotted time by highlighting all of her awards and recognitions, but just a few. Schwab Foundation Social Entrepreneur of the Year, the Draper Richards Fellow, the Shoko Lemelson Fellow, and of course, last year inducted into the CEE Academy of Distinguished Alumni. If you're not already duly impressed, she is also an accomplished brick mason and can equally lay bricks with each hand. I'm not sure any of us could do that. It is really my distinct honor to welcome Dr. Elizabeth Hausler Strand, 2015 Distinguished Lecturer, Build Changes, Founder, CEO, and Heart and Soul. Thank you.
Thank you. That was great. Good afternoon, everyone. I cannot tell you what an incredible honor it is to be here with you today and to deliver the CEE Fall Distinguished Lecture. Before I tell you a little bit more about what we do, let me tell you a little bit about my story. So I grew up in a small town outside of Chicago. Neither one of my parents went to college. My dad, my dad was a bricklayer. So guess what I did for my summer job in high school and college? Like David already said, I laid bricks. And it was a great job. You know, by the end of the day, you could see what you'd accomplished that day. And it was really rewarding physically. You know, it actually takes some finesse to lay bricks. It's not just about strength. So my dad encouraged both my sister and I to study engineering. I did my undergraduate degree at University of Illinois, Urbana-Champaign. Then I worked in the management consulting and environmental engineering field for a while. And when I landed out here at Berkeley, I remember being very excited about the work I had been doing on landfills, municipal solid waste landfills, and trying to prevent leakage from those landfills contaminating the environment. And I remember a conversation I had with Professor Bray right when I first started, saying, I'm really excited to study landfills. And he said, no, we've kind of figured that all out. It's earthquakes. Earthquakes are where it's at now. So thank you, Professor Bray. So then I had the opportunity to study liquefaction. I'm sure many of you have seen this picture already. 1964 Niigata earthquake. And that's the first earthquake where it got the engineering and academic community's attention in terms of what can happen to buildings when the soil liquefies, basically loses strength in an earthquake. So when I was in grad school in the late 90s, there was a lot already known about liquefaction. I studied ground improvement to prevent liquefaction from happening. And again, there was a lot known about it at that time. You could densify the soil, you could, through vibration, through compaction, there was displacement, there was deep soil mixing. There are a lot of innovative ways of improving the ground. But we didn't quite know yet how to optimize this. So how deep and how wide do you really need to improve the soil in order to keep the settlement of a building in an acceptable range? So I had the great opportunity, thanks very much to Professor Sattar, who really convinced me to stay for a PhD by dangling a trip to Japan in front of me. And then I spent every year I had another trip to Japan and did some very fascinating geotechnical centrifuge testing at UC Davis and at the Public Works Research Institute. And toward the end, I got the opportunity to do a full-scale blast-induced liquefaction test. So this was up in Hokkaido, in the North Island of Japan, where we were working on some reclaimed land that hadn't been developed, and with some researchers from around the world, UC San Diego and in Japan, we put a whole bunch of different experiments in this area. We were, again, looking at how deep and how wide do we need to improve the ground. So we've got a series of dead weights here representing buildings. We did ground improvement, and then we set off explosives to simulate liquefaction. So let me see if I can get things to play here. So a little bit more intense than an earthquake. You know, we worked. How do I make it stop? We worked from dawn till dusk on this experiment, and then it was over in a couple minutes. It was really a fantastic opportunity here. But I figured that's probably enough, right? It was great. I love problem solving. That's really what engineering is about, problem solving to make the world a better place. And this was fascinating research, fascinating engineering. But it still felt a little bit like it was not quite as connected to people, not quite as connected to the end user as I really wanted to be. I mean, that's what engineering is. It's using technology to solve a problem or make the world better. But you've got to do that in the context of a financial constraint, usually. If you invent something that's too expensive, it's probably not going to be adopted at a large scale. And if you invent something without considering your end user, without recognizing people, then it's probably not going to be adopted at a wide scale either. So I felt a little bit that that was missing. And so right around the same time, there was an earthquake in Gujarat, near Bhuj, in Kutch, India, in 2001. And for me, like the Niigata earthquake had this huge effect on the academic community studying liquefaction. It was that earthquake in 2001 where I really started to think about how many people are killed in an emerging nation when their house collapses on them. And so that was a real turning point for me. And like David said, when I started Build Change, it was two things. It was about an engineering challenge. I love engineering challenges, just like I'm pretty sure every one of you do. But it was also a social justice issue because I felt like everyone deserves the right to a safe house, regardless of their income level. So how do we solve that problem? So I went to India on a Fulbright fellowship, and in addition to spending a lot of time in Kutch, I got to travel around to some other parts of India where there had been an earthquake 10 years previously. This was 2003 when I was there. And I visited eastern part of Maharashtra where there was an earthquake in 1993. And I found these folks living in this dome house. So what do you think about this dome house? Probably very good for earthquakes, right? But would you want to live in that? I asked those folks that same question, and the answer was a very strong no, because there are no windows, so the ventilation is very poor, natural light is very poor, it's very difficult to divide the interior space. And when folks go to expand the building, because this is too small for their extended family, they go about using the same sort of poorly reinforced masonry techniques that they were using before the earthquake. So by coming in with a technology that's not appropriate to the culture and the climate, we miss the opportunity to train people with the building technology and architecture that's locally appropriate. So in another village, I met the folks who live here. And I said, what is this shack on the back of your building? And they said, well, that's where we sleep. I said, why do you sleep out there? And they said, well, a contractor built our house. And we don't believe that the contractor used enough cement in the concrete. So we don't trust that this house is going to survive the next earthquake. So we're sleeping outside 10 years later. So it may seem like the way of approaching post-disaster housing is to go about and build the same house for everyone really fast, economies of scale. It seems like a good idea. But the reality of it is, if you don't involve the homeowners in the process, they may not trust the structure is safe. And if we're dealing in the context of a post-disaster, where people are already traumatized because they've been through an earthquake, they may have lost a family member, that's the last thing we should do as engineers, is put them in a building that they don't feel safe in. But the Indian government had learned some lessons over the years. And so when the 2001 earthquake came along, they tried a different approach. Instead of giving away houses, they decided to provide people with cash and technical assistance. So a cash grant in installments, an engineer to help design the house, working together to produce something that the homeowners really felt confident in. And this had a much, much better approach. You talk to these people and they're happy. They're satisfied with their home. So this woman was able to, instead of just getting the cookie cutter house, was able to design in a porch so she could get out of the sun in the shade. And also to be able to design her roof so she could store livestock. So we've got to work with homeowners. We've got to understand the needs of our end user and work with them to build safely. So I started Build Change with that idea. The idea that instead of giving away fishes, we would teach people to fish. Instead of building houses for people, we would work together with homeowners during the process, enable them to design, and create opportunities for us to train builders and engineers and everyone involved in the construction sector along the way. So 11 years later, there are about 250, about 250,000 people who are living in safer buildings because of our work. We've trained about 24,000 people worldwide in the basics of safe construction, and we've created about 11,000 jobs. We're now operating in 6 countries, Indonesia, so shortly after the tsunami of 2004, the Philippines, Nepal, Haiti, Colombia, and Guatemala. So just to give you a little bit more of an example of how this works, I'll tell you a story about Xing Dayan. She lost her house in the 2008 Wenchuan earthquake in China. When we met her, she had actually already started building a new house. And this is a confined masonry house. You can see it in the background here. So across the emerging world, we are dealing with masonry buildings. And our philosophy is to work with people to improve the way they build rather than introduce something new. But we're dealing with masonry buildings, which can be a very vulnerable building in an earthquake if you build it incorrectly. So it's a masonry, it's a shear wall, load-bearing masonry building. So the idea here is that you've got to have walls in order to withstand an earthquake. And she had one wall that was going up like this, and she had another wall where she had a window and a door right together. That's a lot of opening in a wall. And so, but we can't go along and tell people, well, you can't have a window and a door. We know that's not going to work, right? So we told her, well, you've got to tear down the wall that's going up like this and build it over. That's one thing. And then let's put some reinforcement over the window and door. And she was able to work with her contractor to get that done. We didn't give her any money or materials. We just told her what she needed to do. And she got a contractor to do it, and she told us that all of her neighbors then wanted reinforcement over their windows and doors as well. So that's the kind of long-term change that we're trying to make. So people often ask us if any of our houses have been tested by an earthquake or a typhoon, and we've got 2 cases of proof of concept. We work with some homeowners to rebuild after the 2007 earthquake in West Sumatra, Indonesia. Most of those folks are actually building timber frame with a masonry skirt wall. And then another earthquake came along in 2009. None of the houses that met our minimum standards had any damage. In Philippines, we've been working since Typhoon Yolanda. This is one of the confined masonry homes that we help people to build there. And then Typhoon Ruby came through about a year later. And we've heard that 50 people sheltered in this house. It's kind of hard to believe, but that's what we've been told. And there was no damage and everyone was safe. Okay, so here's my first lesson for the engineering students about how to become a great engineer. So you're in this wonderful, safe environment here at UC Berkeley. And you've got this opportunity to learn the code, to learn how to design whatever it is you're designing. And it could be a house or a bridge or a water system or whatever. That's great. Then you graduate and get a job, and you hopefully have the opportunity to apply the code, hopefully under a great mentor. But then the ultimate goal really should be to use judgment to optimize the code. So Build Change does structural engineering design, usually trying to achieve a life safety performance objective for our houses. But what we found is that what I mean by going beyond the code is that sometimes the code can be a little bit too conservative, and there are changes that we could make to make the buildings more affordable and therefore reach more people with safe building technologies. And other times, the code can be a little bit unconservative depending on how we apply it. So we found that, again, since we're dealing with masonry, that the codes will assume the strength of the wall based on the compressive strength of a brick. That seems like a big assumption, doesn't it? Especially in a case like what we have in Indonesia, where the bricks aren't very strong. They're fired in these roll kilns. It's pretty hot there. And if you lay the bricks dry, they will absorb the water out of the mortar before the cement has time to hydrate and stick the bricks together. And so you can pop the brick off with your hand. So we're assuming that the strength of the wall is just based on the compressive strength of this brick, but we haven't glued the bricks together. So that doesn't make sense. So we have to pay attention to these construction issues. On the other hand, we found that a lot of the codes ignore plaster, ignore the strength of plaster. And again, we're working with low-strength masonry that can be vastly improved if we put a cement-based plaster on both sides. So we need to be able to go beyond what we learn about the codes in order to really optimize the design so it can work for our end user. Okay. So I'm mostly talking about sort of very basic technologies that have been around for years and years and years, masonry. So we also use some more innovative technologies. We use tablets to collect data now. We've expanded on some apps that are normally used in the insurance industry to inspect buildings. And we use text messaging to get the message out about safe construction. So like I said, in Indonesia, it's really important to soak the bricks in water before you build the wall, because then you can prevent this phenomenon from happening where the mortar dries out too quickly. So here's one of the ways we do that, through text messaging. And you can tell me if you think our star here is bound for Hollywood. Message from Build Change. Good afternoon. Have you soaked your bricks before laying them? So he's having it up a little bit, but you get the point. I mean, we've done some very basic testing that indicates if you do this, you can double the strength of the wall. So it's an important step. Okay, halfway, now we're going to the opposite side of the world in Haiti, where the most common building material is a concrete block, a CMU. But we have the same challenges with good quality masonry and good quality building materials. You know, the concrete blocks made in Haiti can be really variable in quality, so we've done a lot of work with the producers to produce a stronger block. And the thing is, though, we've got to convince the consumer, we've got to convince the purchaser to purchase a higher quality building material. And it's a little bit more expensive, and it's difficult, it's really difficult, and you can do it, but it's difficult to look at a block and tell the difference. So here's one of the ways we try to convince people how to tell the difference in Haiti.
A system to test the block, not to test the block as precisely as an industrial machine, but it can allow a client or a block maker to test a block and see if it is a good block or a bad block. So it is a very simple system that we tested, we calibrated in order for the block makers to use it wrongly.
Pretty basic, but you know, there's a lot of engineering that actually went into this, you know, determining the drop height, determining how to hold it still, what surface we should drop it on. We have actually a compressive testing machine in our office in Haiti. I figured I needed to stick at least one graph into this presentation, so this is the one. And so we do these training programs with these concrete block manufacturers. So here are all our 23 of our concrete block manufacturers over here, and this is the compressive strength. So the red line is their compressive strength before they work with us. The orange line is the compressive strength right after they work with us. And the blue-purple line is kind of a steady state. And so you can see we're having a net increase in the strength of these blocks through these training programs. But now there's a lot more to it than engineering, right? There's a lot more to it than the technical part. Sure, we've got to get that right. We've got to work with them to optimize the type of sand they're using, the cement to sand ratio, how they're producing the blocks. But what we've found with these small businesses is that it's really more of an issue of cash flow. So, you know, again, we're talking about a cement-based product. So we need time for the cement to hydrate and create a good bond between the aggregate particles. So we need to leave the blocks in the shade and keep them damp before we sell them. So you're asking these small businesses, these little side-of-the-road businesses, to hold their inventory. And these guys they don't have the cash flow to buy the raw materials for the next batch until they sell the existing batch. So this is a challenge. And so it became not only an issue with the technical part, but also with marketing. How do we convince people to buy a higher quality block? So we have marketing murals and that sort of thing, and the block testing machine that I showed you before. But we're also looking at financing. So how can we provide access to financing for this small business person? So, and we found when we started to look at this, you know, completely not an engineering issue, we found that, well, these guys can't get a loan from a commercial bank because they're considered too risky and they don't have the collateral. On the other side, they can't really access microfinance because the loans that are available through microfinance are too small, they're too expensive, and they have to be paid back too quickly. So now we have a partnership with Foncose, which is a microfinance institution in Haiti, to try to develop a product specifically tailored for these small businesses so that they can grow their businesses and produce better quality blocks. We also have a network. Réseau is the Haitian Creole word. And this is where we're trying to get these professionals together and provide them services and benefits that will encourage them to continue to produce safe construction. And one of the things we've done, by grouping all these guys together, we can actually get them lower cost cement because they're treated as a bulk purchaser. So again, completely not engineering. So these are my next lessons about how to become a great engineer. And that is to broaden your horizons and to work with your colleagues in other disciplines. Because there's so many aspects to what we do that go beyond engineering. There's the financing, there's policy change, there's understanding what really motivates people to build safely. And for that, you need help from your friends. So, and people have asked me over the years if one person can change the world. And I think my answer to that at this point is absolutely yes. but they need so much help from their friends. This is something that you can't do alone. So speaking of friends, we've got about 100 employees worldwide. This is a collage we put together for International Women's Day a couple years ago. 50% of our senior management team is women. 60% of all of our managers are women. And why is this important? Well, because women can be great engineers, of course. But because we find that when we're able to work with the woman head of household, she is more likely to prioritize building a safe house rather than a larger one. There's some great statistics by UN and other organizations that indicate in the emerging world, if a woman is working and she has $1 to spend, she's going to spend 90 cents of that dollar back into the family and the home, whereas her male counterpart is only going to spend 35 cents. So if we really want to achieve change, we need to work with women, and we found it easier to do if we hire women. And I think this is so important because, if you look at some of the other statistics, there are studies that indicate women and children are 14 times more likely to die in an earthquake than men. And so there's kind of this imperative that we really have to work with women in this field to solve this very large-scale problem. And so I'm going to show a quick video of a training program we did for women builders in Haiti in partnership with the World Bank and Sean Penn's organization, JPHRO.
Yo tout a dit que c'est un métier garçon gagné par rapport à gens que des bagages qui disent là-dedans. Même si tu veux que fille qu'a fait.
Mais tout dans le métier, ou adapter avec, ou capable de faire tout ça en garçon qu'a fait, ou capable de faire. Parce que nous sommes vraiment fiers de l'indemnité garçon ma travail. Tout ça nous fait mon fait tout.
And I forgot to mention that our director of engineering is also a Cal graduate and a woman. Thank you. All right, so continuing along the theme of partnerships and working with your friends, you might be thinking that wouldn't this all be so much easier if the government just enforced the building standard? Yes, it would. But there's a lot of reasons why that doesn't happen. I mean, obviously the one is corruption. But what we've found as we've worked over and over now in 7 countries, that there are other obstacles to that. One is just simply budget. We've worked in some rural environments where the Ministry of Public Works or the public authority just doesn't have the budget to get an inspector out on site. They don't have a vehicle. In our program in China, which was in a very rural area, there was 1 engineer and 1,000 houses to be inspected. So we hired a bunch of Chinese technical college graduates, trained them, and they went out and did the inspections. So there's still a long way to go here, but we should at least try. We should at least start to promote enforcement of building standards. So in Haiti, we worked with Doug and Kolb engineers to develop a retrofitting guideline for 1 and 2-story masonry buildings. It's now become part of the national guideline. And we did the first ever training of Ministry of Public Works engineers on retrofitting. And it was a mix of sort of field exercises and practical exercises as well as classroom training. And the classroom training was kind of like 2 weeks of us standing up there giving a lecture. And it got kind of tiring after a while, but on the very last day, we had the Haitian engineers give the training back to us. And this was absolutely by far the most fun part of this, because you can see the enthusiasm. I mean, the engineers sort of took what we had done, made it their own, and ran with it. And that's really what Build Change does. We're trying to put tools, resources, training materials in the hands of people who can take them forward. So, okay. So here's my last comment on how to become a great engineer. Anyone heard of the Harry Potter series? So it came out when I was in grad school here, so of course I read this series, and there's this beautiful moment in one of the books where Professor Dumbledore says to Harry that you're going to have to choose between what is right and what is easy. And I think that applies to engineers as well. When we were working in Aceh in Indonesia after the 2004 Indian Ocean tsunami, there were some organizations that went with the contractor approach where they hired a contractor, built massive numbers of houses, weren't really watching the construction quality. It was really terrible in some cases. You can see it here. You can kind of poke your hand through the wall. The columns are not consistent section. You can see rebar sticking out. this was bad, and we had cases where the homeowners were actually protesting because they knew the construction quality wasn't very good. So we got involved in this from an inspector standpoint, and it was tough because it ended up, the contractor lost a lot of money, and the organization who was funding it also lost money too. And there was one point where I got interrogated by the Indonesian police, and it wasn't so bad at the time because I had a translator, and she was translating out all the aggressive parts. But looking back, it was, But in the end, it was worth it, because how can I sleep at night if they can't sleep at night, right? And so some of these houses got torn down and rebuilt. But we've got to stand up for what's right, especially in this context. Okay, so we just had our 10-year anniversary last year. We decided we were going to create this big, hairy, audacious goal of enabling 10 million people to live and learn in safer houses and schools in the next 10 years. So I want to just make 3 more points about what I'm most excited about, and how we're on that path. Okay. So the first one is Nepal. We've started a program in Nepal since the earthquakes there in April. And there's a lot of interesting lessons to be learned from this earthquake. What you see here is a building on the left-hand side, masonry, with mud mortar, and a building on the right-hand side, masonry with cement mortar. And so you can see clearly this one's damaged and this one isn't. Neither one of these buildings really would comply. Well, obviously that one wouldn't comply, but this one wouldn't comply with life safety compliance with building code either. But it shows you that a small change can make a big difference. And when we're talking about a resource-constrained environment, these are the kind of things that we need to really encourage people to do. So we're working in Nepal. The second new addition to what Build Change does, we're working on schools. So we've been working on housing all of these years, and finally it just dawned on me, why are we not working on schools? A lot of times it's the same structural system, the same issues. We know how to solve these problems, and so we're working on schools now as well. And the third expansion, so we've been pretty much chasing earthquakes for 10 years. And I think it would be so much better if we could work with people to build safe buildings before the earthquake hits, right? So we've got 2 new programs in Colombia and Guatemala where we're working with people to retrofit their buildings before the next earthquake. So this is a picture of Medellin, Colombia, if any of you have been there. Colombia has made a lot of progress and a lot of reduction in crime, increased access to transportation and jobs. This is a metro cable intended to facilitate more access to education and job opportunities in a low-income neighborhood. They've improved neighborhood infrastructure and that sort of thing. But as a result, these neighborhoods have become more densely populated. And though in some ways they've created a more safe living environment for folks, they've also created a more vulnerable one, because you have single-story, 2-story, 3-story, 4-story, unreinforced or poorly reinforced masonry buildings. So we have a partnership with the city of Bogota where they recognize this problem. They have allocated budget to retrofit homes. And so they have a subsidy available. We've been working with a Colombian engineering community, and we've recently had a retrofit manual approved through the Colombian Seismic Code Commission, and we're working with the private sector to do these retrofits in this neighborhood. But I think we need more help, because our retrofit experience and procedures are for 1, 2, maybe 3-story buildings, and we're looking now at 4 and 5-story buildings. So consider this a call to action for the structural engineers and anyone else in the audience that wants to help us work on some of these taller buildings. But I think this is really the opportunity that we have in front of us. How do we work with people to prevent these deaths and injuries from happening before the next earthquake strikes? So join us, come work with us. We have engineering positions, internships, lots of opportunities for people with engineering as well as other backgrounds. If you want to learn more about us, we have lots of different resources on our website. We have very simple posters in local languages. This one in Bahasa, Indonesia, if you can just do these 6 things, it's going to make your house a lot safer. In Mandarin Chinese, proper proportions of cement, sand, and gravel in your concrete. This one in Haitian Creole, how to tell the difference between good and bad quality building materials. A picture guideline in Spanish on retrofitting. Up through some more sophisticated resources. We've been asked by USAID to write up our experiences in this cash plus technical assistance approach through a series of primers. So, that's about it. I am very happy to answer any questions. Thank you so much for your attention. Okay, yeah.
Microphones are walking around. Students will be given preference, and please state your name and year and major and what you do for build change. Okay.
Thank you.
Hi, so I have a question. So to reach your 10 for 10 goal, what sort of ideas do you have for expanding build chains and making it more impactful? Maybe working with public governments more, agencies more? What ideas do you have?
Yeah, that's a great question. I'm glad you asked that because we've been doing a lot of very direct implementation ourselves where we hire local engineers, we train them, they go out and do the work. But in Colombia, we're looking at this as sort of a 50, 500, 1,000, and then the government really does it on its own. So, we're working in a pilot phase where we're really very active in the engineering, in the surveys, in how the financing is distributed in a 50-house scale. Then next year, we'll step back a little bit, and the government and private sector will hopefully do it at 500-house scale, and we'll then step back and step back and step back, and eventually be in really solely a monitoring role. And so we're not going to achieve this by ourselves. We really need governments and the private sector to do this on their own. So eventually we're going to hopefully work ourselves out of a job, at least in Colombia for a start, and then we can move to somewhere else. Yeah.
Hello, Jordan, fourth year. My question is, how did you begin entering these communities and build trust with them at the start of your projects?
That's a great question, and a lot of it is about hiring local staff, and then they go into the community. So we, like I mentioned, employ about 100 people worldwide. Most of them are Haitians or Filipinos or Indonesians or Nepali. And it's really those people who go out and build the relationships. And usually it happens where we'll go out and meet the mayor or the village chief or something and discuss with him or her. We'll start building, and we've seen situations where we start working on one person's house, and then word of mouth gets around that we're able to provide this technical assistance, and then people start coming to us. But it's really important to build those local relationships and to have that local knowledge and be able to speak the local language and relate in that way.
Hi, you mentioned that you partnered with Dengenkolb for one of the projects, and I was wondering how often do you partner with consulting firms and maybe local consulting firms in the countries that you're going into?
All the time. Tim Hart's right here, our very first and most loyal volunteer who's been working with us for 10 years. Yeah, all the time. We've got great relationships with Farrell Alcessor and some of the other structural engineering firms from the Bay Area. And then really, this project in Bogota is going to be driven by local contractors. We're doing a lot of the engineering, design, and construction supervision now, but it really has to be the local private sector that takes this forward. They're keys to creating sustainable change. We just hired a Nepali engineer. She comes from the Nepali private sector, and again, that's, we're putting tools and resources into local hands, and it's really up to them to take it forward.
Hi, my name's Jake. I'm a grad student in civil engineering. My question was about the training of the youth and developing engineers in these countries. Do you work with universities locally to ensure that future engineers are being properly trained, so it's not going back and retraining, but actually training properly from the get-go?
Yes, we do. And we have partnerships with universities as well as with vocational training institutes. In fact, those have been more of our stronger partnerships with SENA in Colombia. It's the National Level Vocational Training Institute, equivalents in Haiti and Nepal and that sort of thing. Because again, it's a great point, just like your point over here, is that we're not coming in being a training institution. We want to build a local capacity of a local institution to do training. And so we've developed this competency-based training where, at the beginning we used to do these trainings where we would just train every builder with every skill, and it took a long time and it was expensive. But now we've gotten it so we've developed these competency-based trainings. So a builder can come in and they can, if they already know how to lay bricks, then they can just show us they can lay bricks. We can check it off, certify them for that, and then they can leave. And it costs less and it's more efficient. And so we're trying to really gear this to our client so that the whole process becomes less expensive and churns out really good quality builders. So in Philippines and in Haiti, we've got these, I should have included this, we've got these training centers, which are very compact spaces where they have various different stations where the builders, as they go through, get to lay bricks, they get to do carpentry, they get to lay out the site in a sort of a progressive way. And these have become really effective.
Steven, freshman. So as just students studying here, what can we do to kind of change how we think or improve what we do here to positively affect the people halfway across the world?
I think just the fact that you're thinking about that is a step in the right direction. But the second thing is it's so important to have the opportunity to go to the field. And I had the wonderful opportunity of having a Fulbright fellowship, and it was a fantastic thing to be able to go out and talk to people. So I would encourage you to take whatever opportunity you can find, whether it's Fulbright or Peace Corps or an internship with Build Change or something, to actually get out there, because it really changes your ideas. We started this retrofit work in Bogota and in Latin America in general, thinking that people would just want to retrofit their homes for safety. The more we started talking to people, especially the folks in Guatemala who are mainly still in a single-story building, the motivating factor is really, can I add a second story? Can we strengthen the ground floor so I can expand, so I can grow my family or I can have a rental unit? So it's so important to get out there and to talk to people and ask the questions and find out what really is going to motivate them to change their behavior and improve their home.
Can I just sort of plug a local program? At the Blum Center, we have funds available for students who are in the scope of poverty and practice minor to go and work and be interns on Build Change, for instance. And Elizabeth's been talking to the folks at the Blum Center. So, there are opportunities to get that before the Fulbright, too. So.
We've had some great Berkeley grads on our team. Like I mentioned, our director of engineering, the head of our engineering our China program, our first ever volunteer. But lately, we've had more people from Cal Poly and CU Boulder. So we need more Berkeley
there's a
students
code
to come
orange
in.
Kara, please.
My name is Riaz. I'm a grad student in civil engineering as well.
Yeah.
My question is regarding ground stability. You mentioned lots of retrofitting and structural upgrades, but that first picture you showed, the building was still intact. It was the ground that failed, which caused the building to fail. Is there anything in your plans that you've got to address that in the future?
Yeah, good question. I'm a geotech, and I didn't even talk about that at all. So one of those primers that I mentioned was on site hazard mitigation and slope stability. So we have looked at that, especially in Haiti, where people are building on steep slopes, and again, using the same philosophy of locally available solutions and locally available materials, come up with ways of retrofitting retaining walls and those sorts of things. But you know what? I mean, the government came out with some requirement that people above a certain slope needed to move. There's certainly efforts in Colombia to move people off steep slopes. And that's something the government needs to do. It's something that's beyond our control. I mean, we can tell people you're on an unsafe slope and you're violating the government rules, but we can't really force people to move. So again, that's something that's got to change from a policy perspective, and we've been working on just mitigating the very local hazard.
Hello, I'm Jennifer. I'm a master's student in the structural program. And especially after a disaster and you're going into a new country, I'm sure there's a lot of demand for service and whatnot. And so how do you prioritize where to go and what to do first, especially in Nepal, for example, where the situation was just so dire and there's so much that could be done?
Yeah, that's a great question, and I think I think we're focusing more on rural buildings there rather than urban ones because we feel that population can't afford to hire an engineer. So if we focused on the buildings in Kathmandu, probably a lot of those folks, especially on the wealthier end of the population, they could probably hire an engineer. And we also don't want to displace a job opportunity for a local engineer. So we're focused on people in environments where normally the folks wouldn't be able to afford to have this kind of engineering services and training. And then in terms of in Nepal, we're distilling a lot of the technical resources down to just a few building types. So we're trying to make technical resources that would apply to a large number of buildings. And we can do this by doing structural engineering analysis on different building types. But then the idea is really to not come up with a prescriptive design for a specific floor plan, but rather a set of design criteria. So, which would say, if your wall is longer than this length, then you need to put a cross wall. Your windows can be between this size and this size. All of the beam column connections have to be detailed in this way. So rules that can be applied to the same structural system regardless of the floor plan. And that's really how this cash plus technical assistance model works, because we want the homeowners to make the decisions about where is their door, where is their window, where is their toilet. And if we just give the same house to everyone, that's not going to work. So we've got to have a clever set of structural engineering design criteria that also includes architectural elements, because people do need to have windows, so that we can apply these to whatever floor plan people want. And you'd be surprised at the variability. We had, hundreds of floor plans in our China program, but really once you started doing it, it was easy to kind of churn them out pretty quickly. I'm not sure.
Hi, Cot, second year student.
Yeah.
In the countries that you're going into that there hasn't been an earthquake yet, do you ever have trouble, like people don't think they need the retrofitting? How do you convince them that it's really necessary?
Yeah, that's a challenge, definitely. And that's what we're working through right now. And that's kind of what I was saying before about trying to figure out what really is going to motivate people to make the change. Is it that they're going to have the opportunity to add a second story? What we're finding in Colombia is that we're competing with the new kitchen. Right? There's an opportunity to get a subsidy to improve your kitchen and your water and sanitation. There's an opportunity to get a subsidy to retrofit your home. And the retrofitting is kind of messy. We're coming in and we might be knocking something down. And so we're finding that we're competing a little bit with other opportunities. And so what we've decided is that we need to pool these together. The other thing that we're finding in Colombia is that most of this subsidy, which is absolutely necessary because I'm convinced that people are going to retrofit their houses without some financial incentive, it's linked to poverty, which may seem like the right approach. But what this actually means is that we retrofit one house here and one house over there. And meanwhile, this person has a 2-story or 3-story house right next door that's going to collapse on it. But this person doesn't qualify for the subsidy because they're not poor enough. And so what we're thinking as we're working through how this is all going to work is this needs to be treated as a public health emergency, kind of like you would deal with cholera, or kind of like you would deal with Ebola, where the entire neighborhood is assessed, right? You could do an ATC-20 type assessment before the earthquake, right, and figure out which buildings need to be retrofitted, and go house by house by house by house and determine and allocate the funding and do this on a neighborhood basis rather than one by one by one. But these are great questions. We're in the early stage of this program in Colombia, and I think there's a lot to figure out. But I think figuring these things out is essential for this working at scale, because if we don't, it's not going to.
One last question. Hi, my name is Juan. I'm a grad student in Berkeley in soil environmental engineering. I'm a Fulbrighter too, like you. And I used to volunteer in that area with Techo. Yeah.
Oh, yeah.
And over 1 mile over that, this looks like Berkeley Hills compared with 1 mile up, that everything is in wood. Yeah. They principally built the first floor and later continue in the advance they get more bricks, more cement. How do you plan and structure a small house? Because they in the future plan to continue growing. How do you plan that after you have a disaster in one of these countries?
How do we plan? I'm sorry, I'm not sure I understand your question.
You do like a first construction after an earthquake or your program, but the people usually continue constructing after that in years. So how do you guarantee, or which technical knowledge give them? Yes, that's because you can see in all the images that they advance like little to little.
We're regularly assuming people are going to build second stories and sometimes third stories, and that's always a challenge though, because you've got to invest more into building a stronger ground floor if you're going to have a second story. So and you know, that's one thing that we've tried to convince our supporters to be more patient, because we know it takes a long time for people to incrementally build these houses, and so we need to be able to go slowly and make sure that the technical resources are there to build safely in the first place.
I think you'll have the reception to ask more questions of Elizabeth, and she'll take them. It's been a fascinating afternoon with you, and on behalf of the college, I'd like to present to you, I think the student groups will be presenting you with a small room
Oh my goodness.
of today's event.
Thank you. Oh, that's so great. Thank you so
in
much.
the middle so we can
Okay, yes, sorry. Standing behind the podium. Oh, that's great. Thank you.
It recognizes our deep appreciation for your commitment to the College of Engineering as the 2015 CEE Distinguished Lecturer.
Thank you so much.
Thanks. To our Cal Seismic Design Team co-sponsors, and to Warren and Marjorie Minnow for providing this wonderful forum. And I hope all of you will join us for a reception right outside here in the Garbarini Lounge. Thank you for being with us today, and go Bears!
Yeah.